Now let's go the other way. So if you're given the name of an ionic compound, how would you write the formula? And the important part of this is that you remember this rule. Ionic compounds have zero total charge. So when we write an ionic compound, the compound must have zero charge. So let's start with something fairly straightforward. Lithium iodide. So lithium iodide, how would we write the formula for that? Well, the metal is lithium, so I'm going to write the metal ion, lithium, with the charge it gets from the periodic table. I know lithium gets a +1 charge because it's in the first group of the periodic table. Now I also see that I have iodide. Iodide comes from iodine, which is in group 17, and all of these elements have a -1 charge. So I'll write I, -1. So I have lithium +1, iodine -1, and remember the total charge here has to be 0. So what do I do next? If I look at my ions, I have a +1, and I have a -1. These charges are opposite, plus and minus, but equal in absolute value. They're both 1s. So what I'll write for my compound is Li, 1 lithium, and 1 iodide. Now I do have one of each, so if I wanted to, I could actually put 1s here. But normally, whenever I have a 1 in chemistry, I don't write it. So if I have 1 lithium ion and 1 iodide ion in my compound, I just leave them without it. Now let's look at another compound. So let's look at calcium chloride. How would we write this compound? Well, the first element that I have here is calcium. And calcium, because it is in group 2, has a +2 charge when it is an ion. So I have my +2 charge on calcium. Then I have chloride. Chloride comes from chlorine, so I'm looking at this group, group 17, and all of those elements have a -1 charge, so I write Cl -1. But if you notice this time, the total positive charge is 2, and the total negative charge is -1. Those are not equal in absolute value. So what do? I need to figure out how many of each ion I need to balance that charge to make the total be 0. The way I'm going to do this is write out what happens if I have more than one of these ions. So if I have 1 calcium ion, the total charge is +2. If I have 2 calcium ions, I would have a total charge of +4. And if I had 3 calcium ions in my compound, I would have a charge of +6. And we're going to do the same thing with the chloride ion. If I have 1 chloride ion, I have a total charge of -1. If I have 2 chloride ions, I have a total charge of -2. And if I have 3 chloride ions, I have a total charge of -3. These are just multiples of my original charge. And what we'll do now is actually find the lowest common multiple, the LCM. You may remember that from math. And in this case, the lowest common multiple is 2. Well, what does this tell me? Well, it tells me that if I have calcium in my compound, I need 1 calcium to get a +2 charge. But in order to get the equal and opposite charge of that, for the negative charge, I need not 1 chlorine, but I need 2 chloride ions in my compound. So what I'll write is Cl2. So this will be my final compound, CaCl2, because in order to have equal and opposite charges, I need 1 calcium ion and 2 chloride ions. Let's do one final one for practice. So let's do strontium nitride. And we have to write the compound formula for this. So first step, where's strontium? Well, strontium is in the second group, so strontium has a charge of +2. Nitride is here in group 15, and all of these have a -3 charge. So we'll write the nitride ion, which is N, -3. We notice that our charges are opposite, but they are not equal. 2 and 3 are not the same. So we have to figure out what the least common multiple is. How many of each ion do I need? So I'll start by writing the ones out for strontium. 1 strontium would give me a +2 charge. 2 strontiums, a +4 charge. 3 strontiums, a +6 charge. 4 strontiums, a +8 charge. And I do the same for nitrogen. 1 nitrogen would give me a -3 charge. 2 would give me a -6. 3 would give me a -9. And you may be asking, well, how do I know how many multiples I have to write out? You just write a few until you think you'll have a number that overlaps. If you write out both lists and you don't have any overlapping numbers, you'll have to keep going. But usually it's in the first few numbers that you write where you'll find something in common. And in this case, I have the number 6 that's in common as the lowest common multiple. So what does this tell me about my compound? Well, it says I need a total of +6 and a total of -6 for my charge. That means I need 1, 2, 3 strontiums. So I'll write Sr with a subscript 3. And I need 1, 2 nitrogens to get that -6 charge. So I'll write N2. So my final compound is Sr3, N2. So let's finally write out the rules formally for these compounds. So the first rule is you write each ion, so the metal ion and the nonmetal ion, with its charge. And where do you look for the charge? The charge is found by looking at the groups on the periodic table. You'll hear me say this over and over. If you're looking for information that you don't remember, look at the periodic table. All of the information you need is there. So we write down each ion with its charge, and the charge is found by looking at the groups on the periodic table. The next step is we are going to make sure that the charges are opposite but equal in absolute value. If they are not equal, find the lowest common multiple in order to determine how many of each ion are needed to balance the compound. And that's it. That's all you need to know to write these compounds from the name. So you write the ions with their charges, and then you figure out how many of each ion you need in order to have a balanced compound with 0 total charge.